all the way through, we get to pi over 2. These are sine values, so these are the y values. So when we get up here to pi over 2, our y value is 1. So this is mapping out our y value on the y-axis. We continue going around. Now our y values are turning into less than 1. And you can see this little red line is vertical the whole time. So it's tracing out, it's parallel to, and it's the same height as this red line. And so we're tracing out the y values as we go all the way around the unit circle. And now it flips down to negative because we're below the x-axis. Okay, so we're going to go down and we hit 3 pi over 2. So we should hit -1. And then we go all the way back up. And we get back to where we started. So we've done one full period of the sine graph. Okay, so normally I would actually have you do this with spaghetti. And I would have you do it yourself, and it's super fun. But unfortunately, we don't do that. Okay, so that's the sine values. What questions do you guys have before we do the cosine? Anybody? Okay. So now we'll switch to cosine. So I'm going to erase this. Switching to cosine. Let me turn the trace off so I can bring it all the way back to 0. Okay, we're not doing sine. All right, now we're going to trace it. So now our blue is going to represent our x length. Okay, so at 0, we have 1. So we can see our line up here at the x value 0 is at the y value 1. Okay, so then we're going to go up. And my x values are getting smaller. Let me let Amani back in. Her screen was frozen. Okay. So our x values are getting smaller as they get closer and closer and closer to this to the pi over 2 angle right here, and then they hit 0. Okay, and then they're going to keep going around, hit the negatives, go back to the positives, and start at the beginning. So our cosine graph started at a maximum. It started at 1. It went down to -1 and back up to +1. Okay, and these are the x lengths. So what questions do you guys have about that? Okay, if for some reason you're getting confused on your investigation and you want to go back and look at this activity, the link is right here. Okay, and you guys can go back through and do it for yourself. So before we start the investigation, I'm going to go through some vocab. You can write this vocab on the investigation sheet that looks like this. I guess I could have just opened up my document camera. Or you can write it down on a separate sheet of paper. That's fine as well. Let's see, where's my document camera? Okay, so if you're doing it on the investigation, let me move a bunch of stuff out of the way. Hold on. Move this book. Okay, so if you were doing it on the investigation, we're literally just flipping over to the back. Okay, if you just want to grab a piece of notebook paper, that is fine as well, whatever you need. Okay, so I'm going to use several different colors to label this vocabulary. So if you want to go ahead and get out some colors, that would be great. Okay, so I'm going to draw an axis. Okay, and I'm just going to do a random piece of a trig function. Okay, so maybe this is our trig function. It starts and stops right here. Okay, we have our x-axis and our y-axis. All right, the first thing I want you guys to notice is what's called the midline. Okay, so I'm drawing a dashed line that goes through the center of my trig function. It's halfway between my max and my min. Okay, so y equals my midline is how I'm going to write that. See how it passes through the y-axis? Okay, so whatever value this is going to be y equals, and it's going to give me whatever my midline is. Okay, so my midline is this guy right here, and I am just going to highlight it out like that. Okay, and maybe I'll even write a little definition. It's halfway between the max and the min. Okay, what questions do you guys have about the midline? Okay, if there are no questions, we'll keep going. The next thing I want to talk about is the period. Okay, the period is going to be how long does it take to complete one full cycle? Okay, so your period, I'll use this, is going to start and end in the same, no, that's going to be way too dark. It's not going to look the same. Let me find it. Green. Okay, it's going to start and end at the same place, pass through all of our positive values, and through all of our negative values. Sorry that this looks so much like black through the document camera. Hopefully you can decipher it a little bit. So our period is the green. It's how long it takes to get from this spot to this spot. So it's going to be this X measurement here. Okay, and we know that it's that X measurement because we started and ended in the same location and went through all of the possible values in between those two places. Okay, what questions do you guys have about the period? Okay, if there are no questions, we're going to talk about amplitude. Okay, amplitude is going to be the vertical distance between the max or the min and the midline. Okay, so amplitude, I'm going to do in yellow. Okay, and it could be counted here. It could be there. I'm going to put some pen markings in there so it's a little bit more clear as to where our amplitudes are. And you could find your amplitude all the way along this. So maybe this continues very imperfectly. I'm sorry, this should go up. And our amplitude could be calculated between here and here, between there and there. Okay, any of these little sections. Okay, what questions do you guys have about amplitude? Okay, if there are no questions about amplitude, we'll talk about our last thing, which is the phase shift. Okay. The phase shift is a horizontal shift. Okay. So if this were a sine graph, sine normally starts at the midline. Okay, our first point is at the midline. And so our phase shift for this would look like the distance that we traveled to get to that first midline point. Okay. Phase shift can be a little bit more complicated because we could say that this function had shifted to any one of these places. It depends on whether or not you have a sine, a cosine, and if that sine or cosine is positive or negative. Okay, so you have to kind of know what function you're working with to know the phase shift. A phase shift can also go in the negative direction. It can go the opposite way. So you kind of have to have a lot of given information to know the phase shift. Unless you're given the equation at first, and then it should be pretty easy to see the phase shift. Okay, what questions do you guys have about that vocabulary? Any questions at all? Okay, so we're gonna flip over, okay? We're gonna start this investigation, okay? There's some information here. It says like, go to the haiku page and open the trig graphs investigation. You don't need to do that. I had a thing made for it on PowerSchool Learning at one point. It didn't transfer over. So we're just going to go straight to Desmos.com. And I believe I hyperlinked that in the activity for today. Okay, and you'll just click the graphing calculator button. Okay. And you will just type in whatever graph you need there. Okay. So it says today we will be graphing the sine and cosine functions. For each graph, we will start with the parent function. So I give you the parent functions here. Let me make this front. Okay. So the parent function for sine looks like this. It's going to start at the point 0, 0, and go to a max at pi over 2, 1. Hit the midline again at pi, 0. Hit a min at 3 pi over 2, -1. And then we're going to finish it out at 2 pi, 0. Okay. The parent function for cosine is going to start at 0, 1. Okay. So it starts at this maximum, hits our midline, minimum, midline, and then back to our maximum. So this is one period of each of our parent functions. Okay, does that make sense to everybody? Okay, so it says, then we will use transformations to end up with a final graph, A sine of B times the quantity X minus C plus B. This is the same thing, just with cosine instead of sine. And it says our goal is to understand what transformations and key features each constant controls. So we have 4 different constants in here. We have A, B, C, and D. All right, and each of those is in the sine and the cosine functions. All right, they correspond to these vocabulary words over here. So this investigation is going to help us figure out which one does which thing. Does somebody have a question? Okay, so for each function, you only need to draw the final graph on this paper. So put your final graph here. If it helps you to draw the intermediate steps, you may also do that. Be sure to label your final graph somehow. Maybe use a different color pen or pencil. Okay, so you're going to go to Desmos. Okay, and to graph a function, you type y equals, and the function will be in this light blue text box over here in the top left of your screen. And a keyboard with mathematical symbols will be down here.